Hey everybody, here's a little video that's going to help you with your homework tonight. Um, in this assignment, you're going to be solving simultaneous systems of equations using the graphical method. So in our first example here, we've got solve the simultaneous system of equations, 3x minus y equals 10, and x plus y equals 6. And what that means is we want to find a solution that we can plug in to this equation that will also work for this equation. We need a solution that works for both equations. That's what the simultaneous means. It means it's got to be a solution for both of these at the same time. All right, and the way we learned to do that was by graphing each one of these lines. So let's go ahead and do that. Got my table set up here. I'm going to plug in 0 for x. That'll give me 3 times 0 minus y equals 10. So negative y is equal to 10, which makes y negative 10. And that's our first point, 0, negative 10. Okay, I'm actually going to I'll plug in 5 for x, okay? Plug in 5 for x. That gives me 3 times 5. Substitute the 5 in for this x here. Minus y is equal to 10. So 15 minus y is equal to 10. I think we can all see that y is 5 there. So my point is going to be 5, 5. Now, when you're graphing these systems of equations, make sure that when you have 2 points, plot those points immediately and draw your line immediately. Because if you get 2 points here and then 2 points over here and you haven't connected any lines, you might forget which points go to which functions or to which equations. Okay, so I'm going to go over here to GeoGebra, and my points were 0, was it 0, negative 10? Okay, I need to zoom out a little bit. Undo. Zoom out a little bit. So we've got here 0, negative 10. Boom, right there. And the other point was 5, 5. So that's going to be, I need to zoom in a little bit, get my 5 up there. Here we go, 5, 5 right there. And I'm just going to move this so we can see what's going on here. Those are my 2 points so far. Okay. All right, now let's go ahead and do the other line. Here we go. This one's easier. X plus y equals 6. All right, well, I'll choose 0 again for my x. So 0 plus y equals 6, which of course makes y equal to 6. So this point is going to be the point 0, 6. And I could do the same thing by plugging in 0 for y, and I would get that x plus 0 equals 6. So x would have to be 6 in that case. And there are my 2 points. That's a really easy way to graph lines like that. You plug in the x equals 0 and plug in the y equals 0. And what we're finding is actually the y-intercept and the x-intercept, which you'll see here in a second. Go to my point tool. Let's see, so my points were 0, 6. That's going to be right here. And 6, 0 right here. And I called those x and y intercepts because I didn't even follow my own instructions. Are you kidding me right now? So I'm going to go ahead and draw this line here. That was my first line. And my second line is right there. And you can see that these are called the x and y intercepts because this is where the line crosses the y-axis here. So this is the y-intercept. And this is where the line crosses the x-axis. So this is the x-intercept. These two things usually have some sort of real-life significance when we're talking about lines that actually model functions and have real-life stuff with them. All right, so just to recap, this line represents all the solutions to our equation 3x minus y equals 10, and this line here represents all the solutions to x plus y equals 6. So where can I find a solution for both of these at the same time? The only place that's going to happen is if these two lines intersect. Right there. Let's go ahead and let's take a look at these. What is this point here? I need to get my algebra view up here. This point is point E, the intersection of F and G, and it's the point 4, 2. Now what that means is, this is telling that the solution is going to be 4, 2. Okay, let's just check really quickly. 3 times 4 minus 2 equals 10. Well, that's 12 minus 2 equals 10. Yeah, that works out. And of course, 4 plus 2 does equal 6. So here's our solution. It works for both cases. All right, let's look back at the graph here. I hope you can see that there are really only 3 options here. Either my lines are going to cross and there will be one solution. I could also have the situation in which, can I drag this? Yes, I can. Oh, I can't drag it because it's stuck to the x-axis. Okay, so the way it's set up, I can't drag this point. But for this particular example, there's only going to be one solution. We can think of examples where the lines wouldn't cross. If you have 2 parallel lines, there are no solutions. And if your lines overlap completely, then there are infinite solutions. There's not a whole lot of that on your homework, so I think this example is the best one, and I'm going to leave this up here for now.